The last type of logarithms we're going to talk about are natural logarithms. These are the guys that correspond to the LN button on your calculator. Okay, if you kind of glance at some of these down here, you can see that if you encounter a natural logarithm, you're just going to see e. You are not going to see a little subscript indicating the base. So first thing you need to know about natural logarithms is what the base is. They are logarithms with base e. Okay, so remember, e is a number that is approximately 2.71. Okay, you're not going to work with a decimal approximation. If you encounter e, you would work with the entire decimal expansion, e. Okay, so don't round it to 2.71. But natural log means that it's a logarithm with base e. Okay, again, even though e is not the most familiar number to us, and ln might look a little intimidating, you're still going to do it the same way. Okay, that arrow thing. Okay, so basically, natural log of x is the power that e must be raised to in order to get x. Okay, so it's all summarized in this box. Okay, this box is just stating the arrow thing holds for natural log. Okay, so again, if you see this statement, natural log of x is equal to y, that is equivalent to saying e to the y is equal to x. Okay, because if you do the arrow thing, as soon as you see natural log, you can go ahead and write in the base. The base is e. Okay, and then if you do the arrow thing, you would get e to the y is equal to x. Okay, so we're still doing the same thing. It's just, it may be unfamiliar numbers here. Okay, all right, another important bullet, third bullet here. Okay, the functions f of x is equal to e to the x and g of x is equal to natural log of x. They are inverse functions. They undo each other. Very, very important. Okay, we are going to jump straight into the properties of natural logarithms. Okay, again, these are the same properties we saw for common logarithms. We saw them with the logarithms with other bases. Okay, these same properties hold for natural logarithms as well. Okay, so if we're trying to figure out what the natural log of 1 is, okay, you can just write in your base if you want. Okay, so this is saying e to what power is equal to 1. Okay, so e to what power is equal to 1. And we know that has to be 0 because anything to the 0 power is 1. Okay, so the natural log of 1 is 0. Okay, again, another good thing about natural logs, you can confirm all this stuff on your calculator. Okay, so again, you would be looking at your natural log button, which is right here. Okay, again, it's different than LOG. You've got to pay attention to whether you're using LOG or LN. Okay, so if you came in here and you said, I need to know what the natural log of 1 is, you would just type it in like that, and it's going to tell you 0. Okay, and again, that's because if you take e and raise it to the 0 power, you will get 1. Okay, next one. Okay, again, what's the natural log of e? Well, as soon as you see natural log, you can write in your base if that helps you. You don't need to. Okay, but this would be asking, if I take the base, what power do I need to raise it to get this guy? Okay, so e to what power is going to give me e? Okay, the only way those two sides can be equal is if the exponent is 1. Okay, so the natural log of e is 1. Okay, now how you would put this one in the calculator, okay, so you would use your natural log key, so you would hit natural log, okay, and then you're looking for your e button, okay, so your e button, well, on my calculator, it's on the division key, so see it in blue there, so I have to hit second e, or second division there, and that will give me this, okay, so I do the natural log of e, close the parentheses, and it's going to pop out 1, okay. All right, again, think of this, natural log and e are inverses of each other, so they kind of cancel each other out. When they cancel each other out, they leave 1, not 0. Okay, next example, okay, natural log of e to the x. Okay, again, my base is e. I'm trying to figure out what power do I need to raise e2 in order to get the quantity e to the x. Okay, so e to what power is going to give me e to the x? The only way those two statements can be the same, or these two sides can be equal, is if this exponent is x. Okay, so again, if ln and e are side by side, okay, they're going to cancel out and the exponent will come down. Okay, so as an example of this, okay, well, actually, let me write it above so we don't confuse this stuff with example 3. Okay, so let's go up here and do an example of this property. If I told you what's the natural log of e to the negative 10, okay, ln and e are side by side, okay, they would cancel out and the negative 10 would come down. Okay, so that would be your answer. Okay. Last one here. Again, we saw this with the common logarithm and with the logarithms with other bases. This is an exponential expression. The logarithm is in the exponent. So you can't do an arrow thing here. But you do know that e and ln are side by side. And so they're going to cancel out. And then the x will just come down out of the exponent. Okay. So an example of this one, if I gave you e to the raised to the natural log of 12 power, okay, the e and the ln are side by side. They're going to cancel, and so the answer would just be 12. Okay, and all this stuff, you know, you could check on your calculator. You just have to use your e buttons or your ln buttons. Okay. All right. So in example 3, we are going to evaluate each expression. Okay. So basically, we're going to turn each of these into a single number, okay? All right, in the first one, okay, the natural log of 1 divided by 3, okay? Well, remember from this property, the natural log of 1 is 0, okay? So the numerator is 0, the denominator is 3, 0 divided by 3 is 0. So that's the answer to part A, okay? All right, part B. Read it to yourself. This is 13 times the natural log of e. That's how you should interpret this. 13 times the natural log of e. Okay, so this is going to be 13 times the natural log of e. We know from this property up here that the natural log of e is 1. So this is going to be 13 times 1. Okay, that's just going to be 13. Okay. All right, this last property, okay, we have the natural log of a fraction here. Actually, the natural log of 1 over e to the negative, or sorry, 1 over e to the third power, okay? So if you look at your properties above, okay, it probably correlates most closely to this one, okay? It's not quite exactly what we have. It would be great if the ln and the e were side by side so they would cancel out. That's not exactly what we have here, but what we can do is rewrite this guy to be the natural log of, we can move this guy up, okay, and make it e to the negative 3, okay? So remember, e to the negative 3, okay, if I come out to the side here, e to the negative 3 is the same thing as, to eliminate that negative exponent, do 1 over it and then change the sign of the exponent. Okay, so 1 over e to the third power is the same thing as e to the negative 3. Okay, so you can rewrite this in this fashion. Okay, now the ln and e are side by side. They will cancel out and the exponent will come down and the answer is negative 3. Okay. All right. In example 4, okay, we are gonna, I gave you some kind of, I don't know, logarithmic mess that you have to type into your calculator and give me a number, okay? The reason I'm having you do this is because, you know, logarithms are going to pop up if you keep going on in math. If you go to pre-cal, if you go to calculus, you're going to see exponentials and logarithms a lot. You might have to do word problems with them, and then, you know, to solve a word problem, you might have to punch in a number like this to get your answer, Okay, so I just want to make sure you can use your calculator appropriately to get a correct answer using these logarithms. Okay, so in example 4, we are going to use a calculator to evaluate each expression. Round your answer to 3 decimal places. Okay, all right, so type it in. If you have an older calculator, you need to be really careful with parentheses. The newer ones kind of display it as it should be, so you don't have to worry as much about parentheses. So basically what I'm going to do for part A is I'm going to type in the numerator. Okay, so I'm going to hit my ln button. Okay, and I'm going to get the natural log of, in parentheses, I need to do 10/3, close parentheses. So that's the numerator. I'm taking the natural log of 10/3. Okay, I'm going to go ahead and hit enter. So that's the numerator. And then if I hit the division key, it's going to take that decimal and it's going to divide. You can divide it by 0.04. Okay, there is no rounding here. You do not want to round this step to like 1.2. You don't want to do that. You need to keep the whole decimal expansion. Okay, and so that's your final answer there. Okay, so it says to round to 3 decimal places. So usually you take that to mean 3 places after the decimal. So this is going to be 30.099. Okay, so if these are your 3 decimal places, you look at the number after. Okay, for 0, 1, 2, 3, 4, you keep it the same, and then if it's 5 or above, you're going to round up. Okay, so here we're going to keep it the same. So this is going to be approximately 30.099. Okay. All right, so let's type in the next one. This next one involves natural logs and common logs. So you've got to make sure. So remember, for example, if you're doing the log of 50, that's not the same thing as the natural log of 50. So you've got to be very, very cognizant of which logarithms which here. Okay. All right, so to enter this guy, I'm going to put I'm going to enter it in all at once. Okay. I'm going to put the entire numerator in parentheses and then the entire denominator in parentheses. If you have an older calculator and you're dividing something and you don't put the entire denominator in parentheses, it's going to come out wrong. Okay. All right. So this is what I'm going to do to enter the whole thing in at one time. Okay. So put the numerator in parentheses. So I'm going to do open parentheses, 2 natural log of 5, close parentheses, plus log 50. Okay, close parentheses on the log, close parentheses on the numerator. Okay, then I'm going to divide. Open parentheses for the bottom. Log 4, close parentheses on the logarithm, minus natural log of 2, close parentheses on the logarithm, close parentheses on the denominator. Okay, and that's how I would enter it in, hit enter, and that's your answer. Okay, so if we go ahead and round this to 3 decimal places, 0.990, the number after is a 5, so we need to bump the 0 up to a 1. So we are going to write down that this is approximately negative 53.991, and that's it.